Hi there everyone. Welcome to the video lecture series on Taylor and Laurent series in complex analysis. I'm Mayur Gohil. In this video lecture, I am taking a very new type of a question and the approach is going to be slightly different over here. So let us see this question. Here they are saying for the function f of z equals to 1 upon z square times z plus 1, find the Laurent series expansion about z equals to 0 and then they have set z equal to minus 1 and determine the region of validity. Now let us see how to understand this question. Now, apart from traditional way of solving the question using the partial fraction, of course, doing partial fraction is possible over here, but I'm going to take a different approach over here and going to show you how we can do this kind of question when you have one of the uh, expansion origins as 0, okay, or some factor is having the root as 0. Now see here, the function f of z is equals to 1 upon z square times z plus 1. Now the denominator becomes 0 at two places, right? So denominator, if I write over here, I'll just write here, denominator becomes 0 at z equal to 0 and z equal to minus 1. Okay, if you put z equal to, or let's say z1 and z2 equal to, so put z1 equals to 0, it will become 0, and if you put z2 equal to minus 1 in this denominator, this will become 0. So this is what is happening over here. So how to handle this kind of expansion and how to go about it? Now they are saying the center Laurent series about z equal to 0. Now about z equal to 0 meaning the center is origin. So now that means we are going to have mod z. Now where all this is becoming the denominator over here. So see, we have to write down the region over here. So how to write the region? So region, first of all, when they have told us that center is 0, it means we have z minus 0 equal to mod z. This is 1. But what is the radius that we have to understand? Now radius, if you want to understand, you see the other point. One point is 0, other point is minus 1. Take the modulus of the two. So when we take the modulus of the two, that is mod of 0 is 0 and mod of minus 1 is equal to 1, right? Now so the positive of these two, so 0, the greater one of these two is 1. So I'll now say there are regions I now decide over here. So the regions are going to be either this mod z is less than 1 and another region, or let's say this is the first region, the second region I will have 1 is less than mod z. These are the only two regions right now for the case z equal to 0 we can understand. Okay, now let us see how to solve this. So for case 1, okay, when z is equal to 0 and region is mod z less than 1. So this is what my first region and the case is going to be. So let us see how to handle this kind of a question. Now f of z in this case is 1 upon z square into z plus 1, right? Now you try to see this function in a different way. I can now see this as 1 upon z square multiplied by 1 upon 1 plus z. I am now trying to write it in this manner. And I also have this region condition, that is mod z is less than 1, right? So I cannot expand the following part. Which part? 1 upon z square, because there is no expansion for it. But I have an expansion for 1 upon 1 plus z. So the expansion will be The expansion now here it is going to be, right, 1 upon z square times 1 minus z plus z square minus z cube plus z raised to 4 and minus and so on, it will go on, right? So when I now multiply this 1 upon z square inside the expansion, I get f of z equal to 1 upon z square minus 1 upon z plus 1 minus z, then plus z raised to 2 minus and so on, it will go on. How do I get this? See here. The moment I multiply 1 upon z square into 1, I get 1 upon z square this term. The next time when I multiply 1 upon z square with minus of z, I will get minus of 1 upon z. This is this term. When I multiply 1 upon z square with z square, I get 1. Then with minus of z cube, I get minus of z. This is the term. Then over here, z with z raised to 4, I will get z square. And like that, all the terms will be there. So this is the expansion of Laurent series. See, we did not use anywhere partial fraction. Okay, this, see, these are the tricks that you need to know. Even if you use partial fraction over here, you will get the same answer. There is nothing going to go wrong. Okay, but it is just a bypass, another route. Okay, so but if you use the standard procedure, nothing will go wrong. Partial fraction you use, the same answer will come, but I'm just giving you this expansion. Okay, now let us see the other part. Now when you have the region 2, the case number 2, let me write down here. So for case 2, that is when expansion is about z equal to 0, I mean to say over here also, when expansion is about z equal to 0. Okay, it's about z equal to 0, and now the region is 1 is less than mod z. This is the region. Then how do we proceed? The procedure is going to be slightly different. So f of z is 1 upon z square times 1 upon 1 plus z, right? This is what we have seen. Now we will take z common. The moment I take z common, 1 upon z cube, and here I will get 1 upon z plus 1, right? This is what is going to happen. Now you just write in the proper format, because z cube you take common, right? You have kept it outside, and now you write in the format that you need, because you will have, how do I get that, right? Now again that same story. What you do, 1 is less than mod z, it means 1 upon mod z is less than 1. So bring 1 upon mod z in the partial fraction or in the function. So 1 upon z, I have already got it over here. That's what I have did, right? So instead of going for that classical way, we are, you have to stick to the condition, of course, but now this is just an approach without using the partial fraction. Now 1 upon z cube plus 1 upon z. Now this expansion we will go for. So 1 upon z cube remains as it is, and now the expansion is 1 minus 1 upon z. Then the expansion is plus 1 upon z square minus 1 upon z cube plus 1 upon z raised to 4 minus and so on, this goes on. Now let us multiply the terms a bit more and see. Otherwise, even if you keep it over here, this is your final answer. It's correct. There's nothing gonna change it more. Okay, I'll just multiply and give it to you so that you realize the powers increase a lot. Okay, so here 1 upon z cube minus 1 upon z raised to 4 plus 1 upon z raised to 5 minus 1 upon z raised to 6 plus 1 upon z raised to 7 and minus and so on. It will go on like that. So you see there is some beginning terms are missing, right? So beginning terms like 1 upon 1 minus 1 upon z and all that, they are missing. So this is how in this series they are behaving. So this is the final answer over here. Okay, so for case number 1, when the center was z equals to 0, expansion is happening about z equals to 0, you have two cases coming into the picture and these are the answers. Okay, so remember, this is how we did. Now let us go for the next case. So when expansion is about z equal to minus 1, what do we have to do? We need first of all in our function all across, what is the term that we need? We need all across z minus z is equals to minus 1, that means z plus 1 equals to 0. This is the term z plus 1 term is the term I need all across. Now how do we get that? We will get this in our function by f of z equal to 1 upon, now this, see, z plus 1 is already established in the second term, that is okay. What about z square? That is the place we need to establish the term. So we will now write this as z plus 1 minus 1 the whole square. And now you see this z plus 1 which is there, you will have to treat this as one full part. You can't treat it as one number or one small chunk. You can't just cancel over there. You are treating it as one full part. Okay, now what are the places where this denominator becomes 0? You have to remember that will give you the radius. So now see this z plus 1, so for time being I am just showing, so you put over here, put z plus 1 equal to m. Okay, so it implies that z is equal to m minus 1, so therefore f of m minus 1 is equal to 1 upon z plus 1 will become m, right? M minus 1 the whole square, right? And this is m. Okay, now we are having this. Okay, now you tell me where does this become 0? It becomes 0 at 1, right? It becomes 0 the moment I put m equal to 1, it will become 0. So this means our region of convergence, okay, so the radius region of convergence that we have to still find, okay, there will be two again. So therefore region of convergence are, I'll just write here, let's say I'll write here, first region A will be mod of m less than 1. Okay, this is the first region, and the second region will be 1 is less than mod m. Now what are the outputs over here? You have to generally write in that way, right? So let us see now, because we are writing in terms of m, so what happens to our original series that is now in the blue color? So region of convergence here will be, now see we got M, right? So M is nothing but Z plus 1 will be A, what is that? It is Z plus 1 less than 1, and what is the another region B? 1 is less than mod of Z plus 1. Another thing, now let us go about it. So on solving, how do we get it? On solving we will get, so here the case will become, here we have expansion about Z equal to minus 1 and region, I'm taking the first part now. So here the region is region of convergence is mod of Z plus 1 less than 1. Now when mod of Z plus 1 is less than 1, what do we need to do? We will expand now the function. So let us see how to expand it. So I'll write here with yellow, f of z is equal to, now this 1 upon z plus 1 we keep it as it is. What about the other part? It is 1 upon z plus 1 minus 1 the whole square. This can be written 1 upon z plus 1 as it is outside this one, and now I can write this as 1 upon 1 minus z plus 1 the whole square. Now see, we do not know the expansion of the whole square, but we can derive it. It is very easy. I'll derive the formula over here, which is very important. I'll write it in orange. So I'll call this equation as, let me call this equation with some label over here. I'll call this equation as capital A. Okay. For this capital A, we will now see first the derivation of square 1 upon 1 minus something square and how to get that answer. Let us see first the derivation. So I'll do the derivation here and on orange part. We know here, we know that we know that 1 upon 1 minus z is equals to 1 plus z plus z square plus z cube plus z raised to 4 and so on, right? We know this. Now therefore, what is the derivative over here? D by dz of 1 upon 1 minus z. So derivative is 1. One derivative is 0. Okay, take the derivative on the RHS also. Then z derivative is 1. The next derivative is 2z. The next is 3z square. The next is 4z cube plus and so on. This goes on. On LHS, when you take the derivative, what do you get? You will get the answer as minus of 1 into minus of 1 upon 1 minus z the whole square. That is equal to 1 plus 2z plus 3z square plus 4z cube plus and so on. This goes on, and these expansions are possible when the first expansion is possible when mod z is less than 1. This is also possible when mod z is less than 1. This is also possible when mod z is less than 1. So now minus 1 into minus 1, when you multiply, what you get? you will get 1, right? So here the answer is 1 upon 1 minus z square expansion is going to be this. So this is very very important formula for all of us to remember. So I'll just put it here, very important formula. Okay, remember this formula. This is the most important formula for us now. 1 upon 1 minus z the whole square. Okay, so it is 1 plus 2z plus 3z square, like that. So we can now do that expansion over here. So let us do that expansion for part A over there, the capital A equation that we have written. So here we will have f of z equal to 1 upon z plus 1 as it is, and for part A we had over here 1 minus z plus 1 the whole square. Okay, now you expand this 1 upon z plus 1, this expansion, there is no expansion for this will remain as it is because it is one full chunk. Okay, now expansion for this can happen. So what is the expansion here? Here the expansion is, we use the formula that we just derived, 1 plus 2z. Now instead of z we have z plus 1, so here it will be 1 plus 2 times z plus 1, then 3 times z plus 1 the whole square, 4 times z plus 1 the whole cube, plus and so on. This is how the expansion of this terms will happen. Now you multiply 1 upon z plus 1 inside, then you get 1 upon z plus 1 plus 2 plus 3 times z plus 1 plus 4 times z plus 1 the whole cube, and divided by z plus 1, this will become z square. Okay, and so on these terms will go. This is how you expand. Now let us see the next case, the case number, now we will have the case is this, the case 2. Okay, second case. So case 2, when z is equal to minus 1, or rather the expansion. Okay, I'll write here, when expansion is about z equal to minus 1 and 1 is less than mod of z plus 1. This is the case. So what do we do now in this same partial fraction that we have not the partial fraction, the function that we did. So let us see how to go about it. F of z is equal to 1 upon before even we go about that, what is the condition telling us? This means that it is 1 upon z plus 1 is less than 1, right? This is the meaning. So the function here, what do we establish here? In this, it is this z plus 1 remains as it is. There is no problem. But from the squaring terms, what we will need to do? We will need to, the square terms, we will need to take z plus 1 common. Okay, so the moment I take z plus 1 common from this bracket, 1, I'll take z plus 1 common, so it will become square, and here I will be left with z plus 1 minus 1 the whole square. This is the kind of expansion I will get. So what happens here further, it will be z 1 upon z plus 1 the whole cube, and later on here I will have 1 minus 1 upon z plus 1. This is the center, we keep it unmoved, okay? Z plus 1, it is due to the center which we cannot change. Now this expansion is again in the similar manner like the derivatives we did in the above part. So the expansion now will be f of z equal to 1 upon z plus 1 the whole cube, and now this expansion is of 1 upon 1 minus z the whole square, right? Instead of z we have 1 upon z, so we will write here 1 plus, now instead of 2z we will have 2 upon z plus 1, then there will be 3 upon z plus 1 the whole square, then there will be 4 upon z plus 1 the whole cube, plus and so on. This is how it goes on, and you now multiply them inside this 1 upon z plus 1 the whole cube. Once you multiply it, you will get 1 upon z plus 1 the whole cube plus 2 upon z plus 1 whole raised to 4 plus 3 upon z plus 1 whole raised to 5 plus 4 upon z plus 1 whole raised to 6, and so on. This goes on like this. So this is the Laurent series expansion in this case. So here these are the four cases that we see. So with z equal to 0, when we were determining the regions, we got two regions, that is mod z is less than 1 and 1 is mod z is less than 1 and 1 is less than mod z. That was the region. Here also with z equal to minus 1 we got 1 is more than mod of z plus 1 that we got, and here next time we got mod of z plus 1 is more than 1. So this is, these like we have to take the regions into consideration and we get the expansion. Okay, I hope that you have understood this very special example where we have not used the logic of partial fraction, but this is same, the answer comes the same. Even if you do the partial fraction, the same answer will come with the as with this method that we have done. Okay, I hope you have understood this expansion, and we saw a very important formula for derivation of uh, 1 upon 1 minus z the whole square, whose expansion is 1 plus 2z plus 3z square plus 4z cube. Okay, this is a new formula in our list that we can add it up. I hope you like this video lecture. Please hit like button, share it with your friends, those who find this topic useful and they are having this Laurent series expansion in their syllabus for studying. You gain some helpful insight into the topic from my end. Please subscribe to my channel. Thank you. Till then, keep solving good amount of mathematics.